I already have this on the whiteboard. I don't know. Let me see if I can manage this. Yeah, if y'all can see that, right? Okay. This is what I usually do when I give quizzes. I analyze the results of the data and I make these box and whiskers. So of course I'm going to have more numbers than the warm-up, right? Because if I'm doing this with classes as results on quizzes, I'm going to have 25, 30 something students. So there'll be a lot more numbers when I do this. But we don't need to have like all those numbers to get the benefit of the example. And so I like to do this because it gives me a quick way to compare the classes, you know, and gives me an overall quick view without doing a lot of number crunching, right? So you get the benefit of getting that overall view of how the classes are doing without spending a whole lot of time crunching numbers. That's the benefit of the box and whiskers. And when you calculate the quartiles and the median. All right, so I'm going to go ahead and jump to the whiteboard, but first we're going to find the range, of course, after you put the data in order. C is already in order. Then you got to count how many data items there are, and then we're going to use that to find the quartiles and the median, and I'll point out to you what I sometimes do as well. And then we'll make the box and whiskers and compare the box and whiskers and see what they're telling us. Okay? So the range, you just subtract the highest minus the lowest, so hopefully that's not an issue, but I'll go ahead and this would be 16, right? Whereas the range here would be 17, right? And then the range here would be 16. So all classes roughly have the same range. And just to put this in perspective, the context of these numbers, this was an 18-point test. So you can see a couple people got a perfect score in Class A and Class B, but not in Class C. That's still an A, but it's not a perfect score, 17 out of 18. And no one got a 0, so that's good. So you can see the lower end. All right, let me let somebody in. So if you just entered, I don't want to call you out. We just started going over the warm-up, all right? And so we're going to find the quartiles of these numbers and then make box and whiskers. Okay, I calculated the range of each. All right, so now we want to find out how many numbers there are, right? And so I know you guys know how to count, right? And I thought I wrote that down. Oh, yeah, I did. So there's 9 numbers here and 12 and 15. All right, so I'm trying to keep it simple. Now, you might be able to do this visually, by all means. You know, if you can do something visually, there's no need to go jump on numbers because you might do something silly, all right? But if we're going to do the numerical calculations, the n plus 1's divided by 2 and the n plus 1's divided by 4, right? So 9 plus 1 divided by 2, and then 9 plus 1 divided by 4, 12 plus 1 divided by 2, 12 plus 1 divided by 4, and then 15 plus 1 divided by 2, and 15 plus 1 divided by 4, right? Okay, and then these are just going to get us the positions. They're not going to get us the actual values because that depends upon the numbers that we actually have. All right, so this is going to become what? 10 divided by 2, 5.5, and 10 divided by 4, 2.5. All right, and then this is what? 6.5, and then this is 3.25. All right, so we don't have the 0.75 issue, okay? So when we do the divide by 4, 2.5 3.25. Remember, if we get a 0.75, we got to add a 0.25 to correct the issue. God, my face looks like my shirt. Right? And then the same thing here. Now, here we're going to get 16 divided by 4, so we get an integer. All right. So 2.5, in between the second and third number from the bottom, in between the second and third number from the top. 5.5, 12 would be the fifth number, 13 would be the sixth number. Okay, so 8.5, 12.5, 16.5. Oh, wait. You know, guys, I realized I just made a mistake. This is why I do this earlier. Look, I'm dividing by 2, right? What's 10 divided by 2? It's not 5.5. Oops. Sorry about that, y'all. Okay, so the fifth number. Okay, and then notice you have 2 in each little interval. And the 12 is a boundary between the upper and lower half. Okay, all right, and then here, same thing. So 6.5, 3.25. All right, so in between the third and fourth number from the bottom, in between the third and fourth number from the top, in between the sixth and seventh number, so in between the two 11s. All right, so 5, 11, 15. All right, and now we got 15 numbers, so 7.5 and 4. So the fourth number from the bottom, the fourth number from the top, in between the seventh and eighth number, so in between the 9 and the 12. Okay, and I'll just write 12 here. So then 3 in between the 9 and the 12. Now, if you don't know that, you can do 9 plus 12 divided by 2. So I do half of the interval. So the interval's 3, half of 3, 1.5. So I add 1.5 to the 9. That's what I do. All right, then 15. Okay, so now we can make our box and whiskers of the 3 classes and then see what they're telling us. We've already got the numerical values that we need to do that. That's called the 5-point number summary. All right, so for class A, I'm going to put a dot at 2, and I'm going to put a dot at 18. In between 8 and 9, I'm going to put a line above, and then 12, and then in between the 16 and 17. All right, and I'm just going to write the letter A here. Now, we got 3 box skin whiskers. One of them we can put on the bottom, right? Now, depending on how you want to do this, do you want to put B on the bottom and then C on the bottom so that it's A, B, C? You could do that. Do you want to stack 1 on top of A and then put 1 on the bottom? You could do that too. I'm going to go ahead and put 1 on the bottom with B and then put C on the bottom. That way we got the order. Okay, so B, I'm going to put a dot at 1 and a dot at 18. And then 5, I'm going to draw a line where 5 is. 11, I'm going to draw a line where 11 is. And then 15, I'm going to draw a line where 15 is. And then try to draw a straight line. And then I'll just do the box like that. Okay, again, my scale isn't perfect here, but even slight imperfections, we can still get a visualization with these box and whiskers graphs. Okay, so then C, I'm going to put on the bottom of that. Put a dot at 1 for C, a dot at 17. Okay, and then a line where 3 would be, then a line where 10.5 would be, and then a line where 15 would be. Okay, so now we got our box and whiskers here. Which class do you guys think did better? A, B, or C? Which overall on this 18-point test, which class do you guys think did better? Well, look at A. It's got the highest floor, right? 75% of the students did better than 18.5 or equal to, because it could be 8.5, right? Whereas B and C have a lower quartile, right? And notice this small whisker down here on the bottom of C. That means 25% of the students did worse than 3, right? A fourth of the class. Makes me nervous, right? And then notice that the median of C is the lowest of all 3. 10.5 is less than 11, less than 12. All right? And then when you look at A, look at A's upper whisker, very small. So 25% of the students in class A, that would be y'all, by the way. Your class tends to be that, A. So 16.5. 25% of the students got an A. 16.5 would be an A. All right? Whereas class C, a fourth of the students did less than 3. I mean, they had no idea, except for maybe the 2 easy questions. So I do this all the time. You know, I'm a math nerd. What can I say? Now, if you look at the passing grades line, the passing grade would be if you got a 9, right? And you can see a larger proportion of students in A if we start measuring the widths based upon the 9. Okay, well, the good thing is 9 is still to the left of the medians of every class. And so above the median would be 50%. So it looks like we got a little bit more than 50% passing in class C. And that's true for B. And with class A, we got pretty close to 75% passing, because that's really close to the lower quartile. So that's probably 70% passing in class A. All by just looking at these diagrams. That's how much that information can give you. And we're not even talking about skew yet. Okay, everybody all right? All hanging in there? I'm hanging in there by 2 threads. One is stronger than the other. That's what I told a friend of mine this morning. All right, y'all. So let's go ahead and look at the homework. Now, next week, we're going to start doing the other side of the statistics, which would be when we're basing analysis on value. So we've already looked at mean, the average. And then on, I guess, Monday, we'll look at what's called the standard deviation. And then we'll use that to rank the data values based upon value. Right here, we're just basing rank on order. And depending on the type of numbers, any particular value could occur at a position, right? That's why you get different medians, different lower upper quartiles when we compared our 3 groups. So next week, we'll start looking at doing standard deviation. I didn't want to do that today, you know, just to make sure everyone's okay with this. Today, we'll review skew again after we go over the homework. Okay, because I just want to make sure that's issues clear. Hopefully this wasn't too much, but anyway, you guys got the solutions, right? So remember, this was based upon the position of the particular values that you see on the box and whiskers. Let me grab that homework real quick so you guys can see how I organize this stuff. So let's see, your homework should be, yeah, right. No, that would be Monday. That's trig homework. Post. probably put it somewhere else. So anyway, 7 and 5. See, I like to use these stem and leaf plots, right? And then when you analyze the box and whiskers from number 5, it looked fairly central to me. It looked, there was a little bit of left skew over here, right? And the box and whiskers didn't look too big. But if you want to subtract to get the sense of width, you can do that too. And when I did that, I noticed that the 68 minus 41 was bigger than the 88 minus 68. And then with the left whisker, I noticed the 41 minus the 34 was a little bit bigger than the 28 minus the 88. So if you don't want to just go by how it looks, you can be numerical. So it did look like there was more on the left side, left box, left whisker. So it's got slight left skew. And that means the mean is going to shift to the left. Maybe not too much, but that's what skew really means. All right, so you can see, if you guys need help in any of this, this is just doing box and whiskers in the medians. Now, the last problem was a little more involved because you had to take the analysis from 14 and change things. So this lightning bolt comes down, strikes out this tallest tree. So this 368 is no longer there, and it becomes 352, which is down here. And so now the particular numbers are ranked without a 368, which bumps down to the first number in the rank, 352. So you're taking the last number and putting it as the first number. That's essentially what happened. And so that's going to shift the values. They're going to, right? And so notice what happens. The bottom box and whiskers kind of shifted. It's pulling down towards the lower end because we replaced the top value, got rid of it, and put it as the bottom value. That's why that happened. Okay, and then I just put the reordering of the numbers from 14 down here. This is a stem and leaf plot. Okay, in case you're not sure what that means. All right, I'm just assuming you guys are okay. Yep, Eliza, you got it. I didn't see what you commented on, so I'm glad. All right, so now we talked about this a little bit on Monday at the very end. Here's another way to look at this. So when you have left skew, that means the mean and the median are pulling away from the mode. That's what that means. And so notice that if the median pulls, that means you're going to have more to the left of the mode. All right, that's why when you analyze a histogram, find the mode, see how many more are on one side of the mode. So if there's more on the left of the mode, that's left skew, and that means the mean is going to pull to the left side of the median. So there's actually more data values greater than the mean, right? Because since the mean pulls to the left, there's this space between the mean and median that's greater than 0. So 0 plus the 50%, since there's 50% to the right of the median. So skew left, more bars to the left of the mode, median shifts to the left of the median, more values to the right of the mean. Okay, same thing with right skew, right? The mean and the median are going to shift to the right of the mode, so that means there's more bars to the right of the mode. The mean is going to shift to the right of the median, so that means there's actually more data values less than the mean. All right, so this is what happens, you know, when you have students who do a lot better than the rest of the class. They shift the mean And even though the mean is big, there's actually more students that did less than the mean. Okay, so to review, right skew, more bars to the right of the mode, mean shifts to the right. There are more values to the left of the mean. Now we call this also negative skewness and positive skewness. Negative because if you go to the left, that's going in the negative direction on a number line. And we call this positive skewness because as you go to the right, that's going in the positive direction on a number line. So that's what that's called. Okay, so you guys got some homework tonight. Now I put it here too, but this is just the textbook. All right, so if you want to do it here, I also posted it as a separate clean PDF because this isn't really all that clean. Okay, and so you can guys see what's coming up. It's just a summary of all the stuff we've been doing. All right, I don't think you have to calculate the mean in any of these things. So, okay. Okay, anybody got anything? Any issues? Okay, so I'm good. If you guys are good, y'all take it easy.